everyone. Standing room only. There are a couple of chairs, maybe. Come in. So welcome. Who here loves Go? Yes? Awesome. Who here knew that Go was used with MongoDB? Good, good. Awesome. Well, today we have a panel here of speakers. We have Timothy, Mike, Luis, and Ian, and they are going to present to us the use and history of Go in MongoDB.
Thank you, everyone. Sorry about the arrangement. I want to just, for the first bit, introduce Lisa Berger, Mike O'Brien, and Tim Olson. And I'm going to get them just to speak a little bit about who they are and what their team builds with Go before we go into some questions. And as we move through, we'll probably take a few from the audience. Just bear with us as we hand the mics around and stuff, okay? I'll just go. Luis, did you want to introduce yourself and tell us a little bit about how you and your teams use Go in MongoDB?
Sure. My name is Louisa. I'm the Director of Engineering on our Cloud Automation team. I've been at Mongo for about 10 years. I think Mike has me beat, but we've all been here a while. My team uses Go for a number of things, but mainly to build what we call agents. So pieces of software that we install on machines that take care of process management for MongoDB deployments. And I'll let Tim talk about the second half because he's on my team too.
Hi, my name's Mike. I'm a Director of Engineering on the Device Sync team at Mongo. So I've worked with Go in the past at MongoDB on a bunch of different teams, including Evergreen and the Mongo tools. And on the Device Sync team, currently we use Go for all of our backend infrastructure. So Device Sync is a cloud service that is handling requests from devices such as mobile phones, IoT widgets, things like that, to handle requests over WebSockets that are syncing devices, data on devices to MongoDB clusters in Atlas.
Hi, I'm Tim. So I work on the automation team with Louisa. I've been working at MongoDB almost 9 years now. I think Louisa, what Louisa was getting at, we also use Go for the Atlas free tier proxy. Yeah, I remember I basically joined MongoDB in July of 2013, and Kaylin Nelson at the time, who's now senior VP, had told me, you should learn Go. And so that's what I did when I first joined MongoDB.
I think that leads to the first question. Well, I think what prompted the change in MongoDB? I'll ask you each to chime in, or if you want to delegate amongst yourselves. Cloud and the MongoDB monitoring system originally started with Python and Java. And as the company moved and as the cloud products moved towards SaaS, I think it would be interesting for the audience here to learn why was Go picked as a platform and a language, and specifically what made Go appealing at that point in those earlier days.
So for the MongoDB agents, which do the process management stuff, we did build the first version of monitoring in Python, and then we rewrote that with automation and backup in Java, and then we rewrote it again in Go. And the reason that we landed on that was mainly for like the cross-compiling makes it really, really easy. So since this is a piece of software that gets installed on many different types of operating systems and build platforms, we needed to be able to build it across everything. And since it needed to run on customers' hardware, we needed to also not have them need to have other dependencies and that kind of thing. So that made it really, really easy. That was the main motivator for us. And then it was very easy for the team to pick it up, and that's part of why we've stuck with it as well, as it was easy for development. it was also a bonus that we then had. I see a lot of the MongoDB drivers team is in the room. They then built the Go driver within Mongo, and that was really helpful as well to have that as like a building block for our software as well.
So when I was in the early days of Go adoption at MongoDB, the project I was working on was Evergreen. And Evergreen is a continuous integration system, which we built in-house to handle running our tests against the Mongo server. And part of that challenge is making sure that the tests pass on every different platform, different kinds of Linuxes, different kinds of Windows, and we also even had some more exotic platforms like Solaris used to have a build for MongoDB. So Evergreen at the time used also an agent which would run on each platform to kick off the tests. So being able to write one agent that you could deploy to any of those machines and run the tests was super easy. And then an advantage over, say, Python is that you don't have to think as much about what version of Python is the default on that platform, what libraries does it ship with. If you compile it once, or you can cross-compile it for different platforms, there's a pretty good chance that it will work fine on any of those. So that made it a really natural choice for Evergreen. And also just the fact that the language was so easy to pick up, and the project was very new, so we had new people coming on the project. A lot of whom were interns and new grads. They could ramp up pretty quickly and be productive within just like a couple weeks.
Yeah, I mean, just to further elaborate what both Louise and Mike said, static compilation, right, was the big thing, because the monitoring agent, which was the first agent written, was written in Python, and we were having lots of issues with customers being, customer support being like, well, you have to have this version of this library, and what version of Python, like Mike just mentioned. So I'm not exactly sure why Java was first chosen, but maybe for performance reasons, or I guess you could sort of put everything in a jar, but then you have to have a JVM on your machine. So the ability to just hand over a binary, right? And when I say static compilation, if you run LDD on the binary, it's still an ELF, and you'll see it linked to C libraries. But the Go libraries themselves are statically compiled, right? And so that was the number one thing, but also just the general language itself, right? It was just like the next evolution of like what I call algol-derived languages, C, C++, Java, and coming out of, sponsored by a good company like Google, was strongly backed by them. Lots of experience, from Rob Pike as a co-creator of Go, and our CTO at the time, Elliot Horowitz, was very much pushing Go and saying he thinks this is a good choice.
Jumping straight in onto the points there, the static compilation and the cross-platform builds as major advantages, and two really important projects, I suppose, in the development and maturity both of engineering and of the company, with Evergreen, our continuous integration system, and also the agent. And this is probably more a broader question. How do you think, firstly, the success of those projects, so they're both very successful and both key and core to our day-to-day of our SaaS platform and of our packaging and build, and our testing as well. We test everything with Evergreen. Because we're very highly visible, how do you think they contributed to the normalization in terms of accepting Go as a language? Because we've obviously C and C++ in the database itself, and it was a new language at the time. We have Java as well in the rest of cloud engineering, but it was a new language, and a new language is always a difficult choice, and you need successes, and those were good, successful projects. So that's one question. I'll immediately then throw the next one after it. How many engineers and how many teams on a day-to-day are building and using Go? So firstly, the first question is how do those two projects help normalize the adoption of Go? And then just for today, how many teams and how many products are we building with Go?
The second one is easier. Mike and I were talking before this, and we think it's maybe like 80-ish was our estimate.
We should find out.
It might even
Curious.
be more because we have the Go driver, which is like enables not only us to use Go, but also lots of our customers to use Go to connect to their MongoDB deployments. And then a lot of our cloud team now codes in Go as well. So they work in both our agent and the Atlas Proxy free tier and serverless that we were talking about. And often what we've been doing is when there is a new piece of software like that to build, we often do end up choosing Go. So I'd say the number is also increasing.
Yeah, I was going to say also for the first question about how it normalized the adoption, I think a big factor also was that we have the new grad rotation program, and which is it's like every for the new grads that start at MongoDB, there's 6 to 8 weeks of working on a team and then switching to another team, and they do that for like 3 or 4 rotations. So all the new grads that rotated through any team that happened to be using Go got like a crash course in using Go and a lot of practical experience with it. And so after, a year or two of that, you had a crop of engineers who had all been exposed to Go and enjoyed using it. And then that made it kind of shoot to the top of the list for new projects that were about to be started. Go was a natural choice because you had so many people who had already worked with it and liked it.
Yeah, and plus projects what we were writing in it were succeeding, right? And so I explained before why we had to rule out Python, Java for certain things, right? C++ is a natural choice for MongoDB as a database for performance reasons, right? But for stuff that is less performance critical, you can make the trade-off to say, well, I'm going to increase developer productivity at the expense of a little bit of performance, right? And so that's what Go is a simpler language, right? And it's garbage collected, right? So if you can take that little bit of performance hit, right? And I'm speaking generally, right? As we know, we can all fudge benchmarks. You're going to choose that for other other projects, But in places where you don't have to distribute a binary, or you already have a JVM and you want to interact with Java, maybe Java is a better choice. But in general, it was succeeding, and language that was easy for people to pick up, and if multi-core hardware, it has a good concurrency model, stuff like that.
I have enough questions to fill an hour and a half, but I don't want to be greedy. I will walk the room now if anyone would like to throw a couple of questions from the room. Has anyone an interesting question? Yeah.
Thank you. When it comes to the Go, the first answer obviously we just get from wherever the Go has been used is a cross compilation. But other than that, what are the other features like you are leveraging? So it could be a CLI development is also that easy, and then the other is in the recent one they have an embedding feature or file system base. So any other like a web kind of a layer also packaged as part of a single binary other than the agent. Any other use cases or reference would be really helpful.
I think Tim just touched on this a bit, but I think the way that concurrency works in Go is really easy for people to pick up. So that's really helpful that you can write like multi-threaded programs very easily. We use that a lot in our code. So that's been cool to see that, like we were saying, a new grad who's just learning Go can easily write a good concurrent program. That's really helpful. That's one of my favorite features.
One of the features that in Realm and app services that we take advantage of that has been pretty useful is CGo, which I guess it's ironic because it's not Go, but it's the ability to call into external libraries that are from C++ or C or whatever. So we, like the Mongo server, for instance, is written in C++ and has some components that we want to be able to use from Go libraries. For example, the matcher library. So like the query engine for executing match expression on a document. So we can actually have the server team build a library from the C++ code and consume it from Go. So we can have all of our Go servers call into C++ code if we really need to. So if there's ever, even though most of our code base is, or all of our code base is Go, but if we really need to dip into external projects in MongoDB that are built in C++, we have the option to do so. So that's been a nice bonus.
Well, Louisa stole my answer, but no. But the other great thing about Go is that it compiles very quickly, right? So I think the server team, when they code in C++, they have C build or something, so they can, share build artifacts and all that, and it's quite the compilation to build MongoDB from scratch. But yeah, Go just compiles a lot faster. And I was explaining before, it's you don't have to worry about memory management for the most part. There's still ways to have memory leaks, but it's just what I was saying earlier: simpler language, concurrency, stuff like that.
So we have the next.
What you don't like about Go?
Yeah, Tim and I were talking about this before, and Tim was like, well, we only have 30 minutes, so I don't know.
Okay, well, that puts me on the spot. Okay, I like languages with very expressive type systems that allow you to express things such that you can express constraints using the type system so that you rule out certain things from being possible, right? So you compile the code, you know certain things aren't going to happen. Whereas sometimes I write code now in Go, and I get to a certain clause in a switch statement, and I'll put panic. This should not be possible, right? And then usually Louisa reviews my code and says, Tim, I really don't want to panic in the code. Can you return an error? So now I got to have this function that wasn't returning an error before, return an error all the way up. And I'm just like, this should be expressible using the type system, right? So I don't know if you have any experience with like languages like Objective-C or Haskell, which have these crazy type systems where you can express certain things. And since to some extent, C++ can do some crazy stuff now with its type system. But, or even in Java now where you have, what is it? It's optional, right? This thing that helps you get rid of what's been called the billion-dollar mistake, the null pointer, right? And so, unfortunately, in Go, you still have, well, now it's called nil. It's still the same problem, but yeah. So that's my number one thing.
Rust is also gaining adoption. Do you find any use case for Rust as well? Rust language.
There's a Rust driver. I don't think any of us have used it at work, but there's a Rust driver that's gaining a lot of popularity in the community. I think the Rust team is maybe yeah, there he is back there. They really love, I've heard that they love developing in it and are very excited about it, and the community is too.
I think we've maybe considered using Rust for a few things in the past, but at the time, one of the risks was that the language itself was still evolving pretty rapidly and was not as stable from an API perspective, whereas Go has been like very, very stable and making very small incremental changes to the language, which has been a nice benefit. So that's maybe one reason that we've steered towards Go over Rust in cases where you might be able to use both.
I know very little about Rust other than I've heard a few features and I'm like, oh, that's so cool. But my understanding is it's for when you want, it's even better performance than Go, right? I don't think it necessarily, I don't know if it has a garbage collection. I think it requires, it does something similar to Objective-C, right, as far as reference counting, right? But I know they had that cool feature where you can specify this lock applies to this variable. right? And so, you know, I think about thread safety a lot, and it's just like, okay, can you then insert a memory barrier in the code that only flushes that variable? And you know what kind of performance? Anyway, I'm getting on total tangent.
Tim loves thread safety, so we can't get started on
Yeah,
that. We'll
yeah.
be here forever.
But it seems to me it's more oriented about even a higher performance and people who really, really love C++. I don't know, but or maybe not so. Maybe that's why they want a new language.
Hey, thanks very much. It's been very interesting. I just have a very quick question. I'm not sure if this is really something I should be asking. I could probably go Google it, right? But I watched the presentation earlier today on the Rust driver, which was quite interesting. And I was wondering, now that Go has generics, are they going to be adjusting the Go driver to have more of those capabilities that we're seeing in the Rust driver?
Kevin, I think you're in the room.
No plans as of yet, but the feedback has been taken. And do we have any more questions here?
Thank you for a panel. Even though with Golang you usually can do a static linking, you still have a dynamic linking on a C standard library, right? And I was wondering, under like exotic Linux distribution that based not on a GNU-C library, but rather than, let's say, Muscle or other alternative implementation of the C library, have you run any Golang binaries in those exotic Linux distribution, for example, Alpine Linux?
Haven't tried that, but I will tell you that we had to recently drop support for RHEL 6 because which version of Go? I think it was Go 1.16 drop support, right? Which gets at this. But the thing is, even if you were to compile a real static binary a.out, right, you still have a problem with the kernel API, right? Right. So you can't. So if something's not backwards compatible when you're running a really new kernel, or I'm sorry, a old kernel, right? That could be a problem. I still think, right? But yeah, you can compile libc into it if you know how to hack the binary compilation that much. But no, we don't try anything crazy like that. We just had to drop RHEL 6, and some customers were not happy.
Hey, my question is about garbage collection. So coming from a Java background, they give you a lot of different choices of which garbage collector to use and thousands of command line switches to tune the garbage collector. Do you find that Go gives you enough levers to pull to tune the garbage collector and balance your pause time with your throughput? Or is this something that kind of Go does magically under the hood for you?
It has a lot fewer levers. Yeah, so I forget which book it was, but I one time I had to learn how to manage all those levers on Java. There was like some Java performance book, or it had like however many chapters on learning the garbage collector, and there's just generally no lever, although we have had garbage collection problems in the past, but that was, I want to say, at least 5 years ago, right? And yeah, if you're burning through memory, like objects, and it could be, or at least used to be, a problem where the garbage collector will often not be able to keep up, or you not reclaim the memory, right? And so, but we don't currently have any problems with not being able to pull levers. It's just a much simpler, it's a simpler garbage collector. And my understanding, I don't know if this is still true, but Java, the language, just has like the most number of person engineer hours, you know, put into a language. Is just crazy engineered, right?
I think Go seems to actively discourage you from trying to get clever with the garbage collection. Like, there are a few levers, but they all have kind of like disclaimers on them. Like, if you touch this, you better know what you're doing. You better have a good reason. And all of the forums and documentation seem to steer you towards, well, you should just generate less garbage. Just think about doing that. So that's something that's come up on the app services code recently. Is we've had trying to cut down on memory consumption in the server, so that if you have like a really bursty workload, you're not at risk of the server running out of memory, because you could have cases where you generate garbage faster than the garbage collector can keep up, and then you're at risk of the server falling over. So we've been hesitant to go play with the garbage collector because it could have some collateral side effects with, if you play with the garbage collector, other things that work fine might start being weird. But the flip side of it is that Go actually does have pretty good debugging tools for understanding where things are allocated and if they can be garbage collected or if they can be allocated on the heap, or the stack. So if you do have like an issue with garbage collection affecting your performance, you can get really nice detailed heap profiles of where garbage is being generated and how long it sticks around in the heap, and then use that as a guide to refactor your code to avoid it, and also to figure out ways to restructure your code so that things that are allocated on the heap might end up being allocated on the stack, and then they just get freed up immediately when the scope terminates.
Hi, I have a question. So does director level position in MongoDB, do you still code in Go? And if no, how do you stay relevant in the language?
We both still code and Go. Definitely not as much as I used to. But I think it's not been too hard to keep up. I think, as Mike was saying, the changes in the API are incremental enough that it's not. I feel like when the last new version of Java had all these new things to figure out. With Go, they're just smaller changes, so it hasn't been hard to keep up with them. I don't know if you feel like that.
Yeah, I think I still code as much as I can manage, and the challenge is mostly keeping up with the code base itself, not anything to do with the language. In fact, I would say like the simplicity of the language lends itself to being able to fit an entire code base in your head a little bit more easily than it would if it was like Java or C++, for instance. So like being able to keep up with all the changes that everyone on the team is making across many different projects, I think has been a lot easier with a Go code base than it might have been with some other choice of language.
I agree with that. We have a Java and a couple Go code bases that we use on our team, and I had to let the Java one go more than the Go has been very easy to keep up with.
I think it's worth pointing out as well that our one of our co-founders, Elliot Horowitz, who was our former CTO, was a very strong proponent of right up the management stack, that if you're technical, you stay technical and you still cut code. I think that's something that is clear all the way right up, even to, I can say this, Kaylin does push changes as SVP of cloud. I've seen stuff come through that she's done. So I think one of the key features about MongoDB engineering is even the management at whatever level stay relevant. Now, maybe not on every piece of the code real estate under them, but I think we enjoy and facilitate that. And I know we're running to time. Okay, I was going to steal the last question, but the thing is, you gave me a smile as well.
Hey, I have a question related to the Go client. So Go client for Kubernetes and stuff, you're allowed to modify a lot of stuff in the cluster itself. Is there any plan for Mongo to expose some of these features which you can do with Realm or the new services with Go? Like, are you planning to expose any of the Go services, like any of the services that you can do on top of your app services with Go client? Like, can I create a function using Go client in MongoDB Realm?
Oh, so you're talking about when you write a function, like, which is JavaScript currently, like to Oh, I see. I don't think we have any plans in the short term, but we've definitely had on our roadmap for a while the idea of adding support for different languages. So in addition to JavaScript, like TypeScript, or maybe like a WebAssembly powered engine that would let you run code written in any language that can compile to WebAssembly, which would include Go actually.
I think we're at time. So I really want to ask everyone to just take a moment and thank Louisa, Mike, and Tim for their time today. And I know stomachs are rumbling, but we'll probably be outside for a few more minutes. If you didn't get a chance to ask your question, you prefer to talk to us in the corridor. And thank you again for your time and your questions and attendance.